Dear student, today's topic is dependence of reaction rates on concentration and rate law expression. In a chemical reaction, always be the concentration of a product or going on increase, and another side the concentration of a reactants is going on decrease. So the first situation, in the beginning of the reaction when time is 0, only reactants are present, so that concentration of product is 0. The second condition, the change in concentration of the various species takes place rapidly in the beginning but very slowly as the reaction approaches the final stage. Law of mass action. At a given temperature, the rate of a chemical reaction is directly proportional to the product of the molar concentration of the reactant. The molar concentration of the reactant is also called active mass. If the reactants is A and B, they form the product AB. So rate of reaction is directly proportional to the concentration of A and B. So convert the language in a significant way. So rate is equal to K, then concentration of A and concentration of a B reactant, where A and B are the molar concentration of a reactant and K is known as a rate constant. So the question is raised in our mind, what is rate constant? So rate of a reaction when the molar concentration of each of the reactant is unity. It is also called specific reaction rate. Means rate of reaction is equal to K, the symbol of rate constant, multiply by 1. 1 means if the mole of a concentration we take 1 and another reactant concentration we take 1, it means rate of reaction is equal to the rate constant. So the characteristics of rate constant: first, it is measure of the rate of reaction. Larger the value of K, faster is the reaction. It means if the 5 into 10 to the power 18 is the rate constant and second rate constant is 5 into 10 to the power 9, it means the first one is the fast reaction and second one is the slow reaction. Students, second point of different reaction had different values of K. It means any chemical reaction not have similar type of a value of rate constant, they have different. Third characteristic of a rate constant is it changes with temperature. It means it is not equal, the temperature is variable. For example, 273, 298, 303. So rate constant is always be varied, they have changed. So the next topic is generate. What are the difference between a rate of reaction and reaction rate constant? So rate of reaction and second side reaction rate constant. First, rate of reaction, point number 1, it is the speed with which reactants are converted into product. It is measured as the rate of reactant decrease in concentration or increase in concentration of a product. It means rate of reaction only say by the speed of a reactant, but in a reaction rate constant it is proportionally constant in the rate law and is defined as the rate of reaction when the concentration of the reactant is unity. It means if the reactant has fixed, they say have a unity, for example mole per liter if the concentration are given. So for equalization we are using the rate constant. The second point of rate of reaction, it depends upon the initial concentration of the reactants. Means if the initial value of a concentration of reactant are not given, so we not say about what are the rate of a reaction. Second point in a reaction rate constant, it is independent of the initial concentration of a reactant. Means rate constant is not dependent to the initial concentration of a reactant value. Third point of a rate of reaction is its units are always mole per liter per type. Means the unit are fixed, but in a reaction rate constant, point number 3, its unit depend upon the order of reaction. So what are the orders? The units of rate constant are changed. So student, in a rate law expression, to express the rate of a reaction as a function of the concentration of the reactants is equal to, for example, 2 mole of nitrogen dioxide plus difluorine gas, they produce nitrogen dioxide or nitrile fluoride NO2F. So rate is equal to K is a rate constant, concentration of NO2, it's a first reactant, and fluorine gas, they are product value. So a general reaction we write, if a general reaction are given with a coefficient value A, B, C, and they are reactants and they form only one product. So rate is equal to the rate of reaction is equal to the K means rate constant, concentration of a first reactant, their coefficient value are write in exponential value, second reactant their coefficient value exponential value, third reactants and their exponential value in their coefficient value in exponential way. So ABC are reactants, A, small b and small c are stoichiometric coefficients, and PQR are power of constant concentration of reactants which may or may not be equal to stoichiometric coefficient. So student, a thing is raised in this point, order of reaction. So what is the order of reaction? The sum of the powers to which the concentration terms are raised in the rate law equation to express the observed rate of the reaction. For example, a general reaction, ABC reactants are form a product. So rate is equal to initial instantaneous value minus dx upon dt. So rate of reaction is equal to rate constant means K. First reactant, their stoichiometric coefficient P, then second reactant B, their stoichiometric coefficient exponential value, and C. So the order of reaction shown by the small n letter is equal to P plus Q plus R. When n is equal to 1, the reaction is first order. So they are dependent on the what are the stoichiometric coefficient they have, and the sum of says about the order of reaction. For example, N2O5 dinitrogen pentoxide gives nitrogen dioxide 2 mole and half mole of dioxygen gas. So rate is equal to the rate of chemical reaction is equal to the rate constant K, N2O5 concentration. So because N2O5 is a 1 mole, so for reaction is say we first order. In a second example, nitrogen dioxide is 2 mole, they gives the nitrogen monoxide 2 mole and 1 mole of oxygen gas. Rate is equal to K NO2 and the exponential power is 2 because NO2 is 2 mole, so they said second order reaction. Third example, 2 mole of NO plus 1 mole of O2 gives 2 NO2. So rate of reaction is equal to K NO2 and O2 is 1 mole. So 2 plus 1 is equal to, it's a third order reaction. Fourth example, H2 plus Br2, they forms HBr, hydrogen bromide. So rate of reaction is K, H2 is 1 mole, Br2 is taken only the 1 mole, 1 atom, so it's equal to half. So it's a 1 and 1 upon 2, it's a fractional order reaction because hydrogen give 2 atoms and bromine gives in a molecular form, but they are given only a 1 atom. So this type of a reaction is known as a fractional order reaction. Another type of reaction is known as zero order reaction, which are not depend on the concentration. For example, 2 mole of ammonia in a 1130 Kelvin temperature in the presence of a catalyst platinum, they convert into dinitrogen and hydrogen gas. Student, this type of reaction is not depend on the concentration of ammonia. So this type of chemical reaction is said to be zero order reaction. Keep this thing in your mind. Zero order reaction is independent of the concentration of a reactant. So concentration reactant is not a point in a zero order. Student, in a table, units of reaction rate constant are given. If the reaction is zero order reaction, but independent on the concentration of a reactant, so the unit is mole per liter per second, or in a gaseous reactant here, so we say atm per second. Student, if a chemical reaction is first order, means the reactant have 1 mole value, so the unit is per second, and in a gaseous reactants always be same per second. In a second order reaction, means if the 2 mole of his reactants are given, so the unit is L liter per mole per second, and liter is converted in atmospheric pressure in a gaseous situation, so we say per atom per second. If the reaction is third order reaction, so the unit is liter square mole minus 2 S minus 1 in a gaseous form atm minus 2 S minus 1. If the reaction order is nth value, means higher value than 3, so it say we to mole per liter then 1 minus n per second and atm 1 minus n per second. So student, keep this thing in your mind. Rate is equal to concentration upon time, means mole per liter upon second. So it's mole per liter per second, means zero order reaction. So rate is equal to R naught for zero order reaction, mole per liter then divided by second, it's equal to K, or K is equal to mole per liter per second. So by this formula we can calculate the what is the order of a reaction. Student, on a display you have seen the NCERT question 4.2. The question is, for the reaction 2A plus B forms A to B, the rate is equal to K, concentration of A, and concentration of B exponential power 2, with K is given 2.0 into 10 to the power minus 6 mole minus 2 liter square S minus 1. Calculate the initial rate of the reaction when concentration of A 0.1 mole per liter, concentration of B 0.2 mole per liter. Calculate the rate of reaction after concentration of A is reduced to 0.06 mole per liter. So student, first we solve this question is stepwise. Rate is equal to, if we take the value, we divide this question in a two segment. First we take the case first. So rate is equal to, rate of a chemical reaction is equal to K, rate constant, concentration of A, concentration of B square. Values are also given in a question. So 2.0 10 to the power minus 6 is given the rate constant. So we put the value of a rate constant. Then concentration of A is given 0.1, so we write 0.1. Concentration of B is given 0.2, and also they are given their mole power is 2, so we multiply by the 2. So after the solve, it is 8.0 into 10 to the power minus 9 liter per mole per second. So the next case, when A, concentration of A reduced, so concentration A reacted with initial reduction, initial minus reduction. So initial value is given 0.1 and the reduction value is given 0.06. It's equal to 0.04 mole per liter. So student, you know rate is equal to K, concentration of A, concentration of B square. Repeat all the value, 2.0 into 10 to the power minus 6 into 0.6, then 0.018 square. So the answer is 3.89 into 10 to the power minus 9 liter per mole per second. Student, so concentration of B reacted initial minus reduction. So the value is given 0.2 minus 0.02 value. So the answer is 0.18 mole per liter. In another question 4.3, the decomposition of ammonia on platinum surface is zero order reaction. What are the rates of production of dinitrogen and dihydrogen if K is equal to 2.5 into 10 to the power minus 4 per mole liter per second? Student, so answer is 2 mole of ammonia gives 1 mole of dinitrogen, 3 mole of hydrogen. So rate is equal to K, and K value is given 2.5 into 10 to the power minus 4 mole per mole liter per second, zero order reaction. So rate of reaction is equal to minus 1 upon 2, because the coefficient in a question is given 2 mole. D, small d means instantaneous change, concentration of ammonia, then divided by dt, then another product dinitrogen, so D, concentration of N2 divided by dt. Then hydrogen, the 3 molar form, so 1 up